Hi there. Having recently completed the build of my Edukit robot, I thought I would give it a go today and try and produce a little video showing it in operation. I've actually made it using the splendid 3D printable chassis, which is a link downloadable from the instructions. Luckily I've got a former colleague at the school I used to teach at who managed to do the 3D printing for me. Having just received a Pizero, I decided it was a good opportunity to use that, so I've actually got it installed just down at the bottom there. You can see it's so small, it's actually quite hard to see underneath this big reddish coloured band, which is actually holding the battery on at the bottom to drive the Pi. Here's the board which feeds the motors, and they're one on either side. And on the front we've got the ultrasonic sensor and detector and the transmitter. And on this side, plugged in via a USB extender lead, I've got a Wi-Fi adapter so that I can actually communicate with it and start the program running remotely. If I pick it up, hopefully it won't fall to bits. On the bottom we've got the LED detector for the black line follower. Not actually using that here, so it's actually partially obscured by the rather large rechargeable battery pack I've got just lashed onto the bottom to drive the Pizero. I am awaiting for a slightly smaller version to arrive, but that's just to get us going at the moment. You can see that that's on and it's providing the current to drive the Pizero. The black battery box in there has got the 4 cells in it which drive the motors, and if we put that down, that's sort of ready to go. And I thought the easiest program to actually show it off on was the obstacle avoidance program, which uses the signal coming back into the ultrasonic detector there when it approaches an obstacle and causes it to back off and rotate and try and find an alternative path. So let's put it down on the ground. You can see that the Pizero is on there. There's the green light. And you saw the battery lights on the bottom showing everything's ready to go. So let's place it down there on the floor. I've got a linoleum floor here, which is quite a good one to choose, and a nice smooth surface for it to run on. And so the question is, how do we start it going? Well, as I say, it's on, I've got a Wi-Fi adapter there and it's on my local network, and I'm actually going to make use of my Apple tablet here, which is running a free SSH terminal program on it, and I've already got it connected on. You can see it's connected to Pi at Raspberry Pi. Excuse the fact that the bottom of the Y doesn't show up. For some reason this program doesn't have the lines spaced far enough apart and it misses off the bottom of the code, and we're in the robot directory there. And so what I'm going to do is just to try and type in a command here, which is going to be Python 3 then a space, and that's going to be followed with, this is program number 8 from the programs which are supplied in the worksheets. So I just have to type in 8 and press tab to complete it, and it types in 8 avoidance pi, and so that's ready to go when I press the return key, and I'll press it now, and hopefully nothing happened. It says command not found, and that's because I can't spell the word Python. So let's just go up and edit that last line. Press an up arrow, which is here. Go back to the previous line, there it is, and we'll go along to the left, and we'll get rid of one of those P's at the beginning. Oops, rat. Do it again. Here we are, back along here. These things never work when you want them to. Back along here, but it just shows it's all real. And I've typed an extra space there, so let's just go one further forward, delete that space, and in fact we'll go back to the beginning. There's a P and to put in a Y there, and that's now the correct line, Python 3 8 avoidance.py. So if we press that return key down here, then hopefully that's fun to life. There we go. Here's the robot coming, and you can see that it's coming for me now, so hopefully it will stop where it gets to be and go trundling off to the other side of the kitchen. This is a bit dodgy, it doesn't like oblique angles very well, but let's see how it goes. I did manage it, it did a bit of a clonk. Let's Let's go to my foot again there, and it's coming over here. Let's just put the camera in front of it, and it's coming off there. Going off to see the cooker, coming to us again, going up there, bouncing away. Let's have a nice camera shot again, up to the camera and then backs away again. That's rather a good shot actually, let's remember that one. And this will be a bit dodgy, it will have a nasty time here in a corner. It's going to just come to a sticky end there. Let's just give it a bit of a helping hand. Once more off the camera, and then while it trundles away, before it completely annihilates itself, it's got wrapped up around a table leg there. It's fairly robust though, it does seem to extricate itself eventually from most situations. Let's just come back here, and you'll see we're getting feedback on here for what it's doing, how far away it is from everything as we go along from the program. I'm going to press the control key on here, and I'm going to type a C, and that finishes off the program, and everything comes to rest. So there we are, the Edukit robot, great little device, works well, and I thoroughly recommend it. Bye.